Welcome to Food Science and Technology 3. I am Dr. Vusi Mshayisa, and today we are going to continue our conversation on dairy technology, talking about milk and milk-related products. Let me start with a serious scientific question. Can I see, with a show of virtual hands, who of you here likes ice cream? I think that's good. If someone did not raise their hand, I would be really concerned about your suitability for food science. You see, today we are not consumers. I want us to think as food technologists. So today we are food technologists. So when you eat ice cream, you experience sweetness and flavor. When a food scientist or a food technologist sees ice cream, they see a complex mixture of multi-phased food systems. How do we define ice cream? What is ice cream? So ice cream is defined as a foam containing air cells. And these air cells, they create what we call an overrun. The overrun is essentially the increase in the volume that is caused by the incorporation of air during the freezing process. So in many cases, ice cream ends up being almost double the volume of the original mix because of this principle where we incorporate air. Now, here's the interesting question. If half of the ice cream is air, why do we still enjoy eating it so much? I think the answer here, it is because the structure, the fat network, the ice crystals, and the air cells, they work together to produce the creamy texture that we all love as consumers and as food scientists. So, ice cream products are not all the same. They all fall into several categories depending on the ingredients that are used. So on one hand, we have got ice cream that is made entirely from milk products. And then on the other hand, we've got ice cream that contains vegetable fat. And we also have what we call sherbet, which include fruit juice with some milk solids. We also have what we call water ice, which is made from water, sugar, and fruit concentrate. I think for us, it is crucial to appreciate that in South Africa, ice cream products are regulated under the Agricultural Product Standards Act, which is R78. Now, I want you to think like product developers. Why would food manufacturers choose vegetable fat instead of milk fat in their formulations? And I know that the possible answers would be, it's because of cost reduction, it's because of shelf stability, it's also because of dietary preferences. If you had any of those answers in your response, you are thinking exactly like a food technologist. Because food technology is always science plus the economics. There's money involved, there's cost that is involved. So some of these products, they offer us a wide range of applications that we can sell if we are operating as a company. But what is the key here in manufacturing ice cream? The magic lies in how these ingredients, the various ingredients, interact with one another. So think of ice cream as scientifically engineered frozen form. In fact, if the structure of the ice cream collapses, you do not get ice cream anymore. You get something that is closer to a frozen milk soup, which nobody wants. And you've seen this when, if there was load shedding that happened and the ice cream sort of became a liquid, then when you freeze it again, it doesn't go back to the same foam or structure that you had. So in the production of ice cream, there are a number of ingredients that are used. And these ingredients, how they play, how they interact together, the symphony of these ingredients coming together is what gives us what we know as ice cream. So in the next slide, I want us to look into these details in terms of what are the roles of each of these ingredients. So now let us look at something very important. Every ingredient in ice cream has a specific technological function. And these ingredients, they are not just added for taste. They work together to build the structure of ice cream that we love so much. So, what are these ingredients that are used? We've already seen them in the previous slide. But let's look a little bit into detail. First, we've got milk. The milk that is used in ice cream provides the rich flavor, smooth texture, and the body that we associate with good ice cream. So you see what happens is that the milk fat contributes to the creaminess and also to the mouthfeel of the ice cream. So the milk solids that are present there also assist and helps to trap in the air in the product. And this, as a consequence, is going to improve the stability of the foam, the structure, and it's going to contribute to the final texture. Next, we have sugar. Many people think sugar is there only to make ice cream sweet. But actually, sugar in ice cream plays another important role, which is a physical role. What sugar does, sucrose or table sugar, it lowers the freezing point of the mixture. And by doing that, it prevents the ice cream from freezing completely into the solid in the freezer and allows it to remain a scoopable ice cream by lowering down the freezing point. So we call this freezing point depreciation. And then, of course, we've got the stabilizers. It was interesting to note that in our scenarios today in class, for these case studies that we were dealing with, we spoke about stabilizers. And so these stabilizers, as somebody also said, I think it was Garabo said, they include ingredients such as gums, gelatin, and really their role here is to bind the water that is present in the mix, so to ensure that there is a structure. So by binding the water, the sugar assists or helps to prevent the formation of large ice crystals. And so you know, from first year, I've always preached this aspect that large ice crystals would make the ice cream coarse and icy instead of smooth and creamy. So what stabilizers do is that they improve the body, texture, and the overall stability of the product. And so milk, sugar, and stabilizers, they don't act alone. Another form of ingredient that is important there is a group of ingredients which are called the emulsifiers. And from our understanding, we know that emulsifiers will include things like lecithin, monoglycerides, diglycerides. What is the role of emulsifiers? Emulsifiers are going to help in the ice cream production to disperse the fat globules evenly throughout the mixture and prevent them from clumping together. So for us, this is important because during the freezing process, the fat globules could otherwise churn into butter particles. In other words, they crystallize. And so the emulsifiers contributes and helps to improve the whipping properties of the mix and help incorporate air in a more efficient way. But we also have flavorants. And these flavorants provide variety and consumer appeals that we see in the market, such as vanilla, chocolate, or fruit flavors, strawberry, and all of those things. And then colorants are added to give the product its characteristics, appearance, and to match, of course, the consumer expectations for a particular flavor. But finally, two components that we often forget when we talk about ice cream is water and air. So in ice cream production, water forms what we call the continuous phase of the ice cream mix, while air is incorporated during the freezing to create what we call an overrun. We're going to speak a little bit about this. So this air contributes significantly to the lightness and the structure of the final product. So when all of these ingredients interact correctly and sufficiently, they create this complex structure that we recognize as a high quality ice cream. So how does an ice cream production line looks like? If you can see in the diagram, so we start with preheating, formulation mix, pasteurization, homogenization, and cooling, and then it goes to aging at around 4 hours, continuous freezing, and then air is incorporated, and then you also add the mixture of fruit and drying ingredients, and then you've got filling, extrusion, and molding, and then depending on the type of product. So let us look at some of the steps in detail. So the first processing step is mixing. All liquid ingredients are combined in a mixing vat and they are heated to around 43 degrees Celsius. Sugar and drying ingredients are then added so that they dissolve properly. But interestingly, fruits and nuts, they are not added at this stage. Why? It is because they are going to disintegrate during processing if we add them here. Instead, they must be added at a later stage. So, because ice cream comes, one of the ingredients that we use is milk, ice cream must be pasteurized. But here there's something important. The pasteurization temperature for ice cream that is used is higher than that of milk. And if we ask the question, why is this the case? It is because the ingredients such as sugar, the fat, has the possibility, the potential to protect bacteria from heat destruction. Therefore, the typical conditions for pasteurization of ice cream would be, if we are using batch pasteurization, 71 degrees for 30 minutes, high temperature short time pasteurization, 82 degrees for 25 seconds. So here we begin to see that pasteurization serves two important purposes. One is to destroy pathogenic bacteria, and then two, it is to improve the ingredient dispersion. And so the second part that we find, the second stage, is going to be homogenization. So we have got what we call complete homogenization and also partial homogenization. So what do we understand by partial homogenization? So partial stream homogenization means that the main body of the skim milk is not homogenized, but only the cream together with a small portion of skim milk. So this form of homogenization is mainly applied to pasteurized market milk. The basic reason for this is to reduce operating cost, and the total power consumption for such a thing you are able to cut with some 80% because you've got smaller volumes that are passing through the homogenizer. So this two-stage process involves extremely high pressures, like 1.7 times 10, 1.7 times 1.7 times 10 to the power of 7 through the first valve, and then 4.1 times 10 to the power of 6 pascals to the second stage valve. So again, the purpose here is to break down the fat globules and prevent them from clumping together. So if this step fails, if there are problems in this step, the fat may churn into butter granules during the freezing process. And suddenly your ice cream becomes something entirely that you did not expect. And so now that we have homogenized the product or the ice cream, after homogenization, the mix is cooled at 4.4 degrees Celsius. This then undergoes a process of aging between 3 and 24 hours. So what happens during aging? So during aging, the fat physically crystallizes, the stabilizers, they hydrate, the proteins absorb the water, and then the viscosity is going to increase. So what this does is that it improves the whipping ability and the final texture of your ice cream. So aging is one of the secrets behind premium ice cream texture, like your what you call stewed fruit and custard, like your stracciatella, and like this one that we like from Woolworths. So what we have next is that we've got the mix, and the air enters the freezing cylinders. These are chilled by circulating a refrigerant between the double walls. So the main purpose of freezing here is that you want to freeze the mix to about minus 5.5 degrees, and you want to beat in the air and subdivide the air cells. So in this stage, freezing, ladies and gentlemen, must be quick to prevent the growth of large ice crystals that would coarsen the texture, and air cells must be small enough and evenly distributed to give a stable frozen form. So the freezing chamber is provided with a special mixing element or dasher. So if you see the rotating dasher with a sharp scraper blades that shaves the layers of the frozen ice cream of the inner freezer as well as they are formed. So the mixing passes through a freezer cylinder which is frozen and whipped at about 30 seconds or less, let's say for example at a temperature from around minus 5.5. So this freezing is going to prevent the insulation of the freezer wall, and it seeds the mixture in many small ice crystals. So small ice crystals means a smooth texture, and large ice crystals means a cheap ice cream. And then finally, the product must be tested. So typically the quality control test will include the overrun, the total solids, the pH, the microbial count, the sugar content, which is measured in bricks, and then you've got the overrun. So the overrun tells us how much air was incorporated. So if you've got too little air, you're going to have a dense ice cream. If you've got too much air, you're going to have what consumers call a fluffy disappointment. So it is important to maintain the integrity and the amount of air that you put into the ice cream. So this brings us to the end of the section on the ice cream. I think the next section will be the various types of cheeses.